let us study the effect of dielectric on capacitance. Consider a dielectric inserted between the plates fully occupying the intervening region. V is equal to E into D, which equals 1 by epsilon naught QD by A, where V is the potential and E is the electric field. The capacitance C of the parallel plate capacitor is then C is equal to charge by potential, which equals epsilon naught A by D. Now let us consider a dielectric inserted between the plates fully occupying the intervening region. The dielectric is polarized by the field and the effect is equivalent to two charged sheets, that is at the surfaces of the dielectric normal to the field, with surface charge densities sigma p and minus sigma p. The electric field in the dielectric then corresponds to the case when the net surface charge density on the plates is plus minus sigma p. This implies electric field equals sigma minus sigma p divided by epsilon naught, so that the potential difference across the plates is given by E into D, which equals sigma minus sigma p divided by epsilon naught into T. For linear dielectrics, we expect sigma p to be proportional to E naught, that is to sigma. Thus, sigma minus sigma p is proportional to sigma, and we can write sigma minus sigma p equals sigma by k, where k is a constant characteristic of the dielectric. Clearly, k is greater than 1. We then have the potential is equal to sigma d by epsilon naught into k, which equals q into d divided by a epsilon naught k. The capacitance C with dielectric between the plates is then C is equal to q by V, which equals epsilon naught Ka by D. The product epsilon naught K is called the permittivity of the medium and is denoted by epsilon. Epsilon equals epsilon naught K. Hence, the potential equals sigma d by epsilon naught K, which equals Qd by A epsilon naught K, which equals Qd by A epsilon. For vacuum, K is equal to 1 and epsilon equals epsilon naught, where epsilon naught is called the permittivity of the vacuum. The dimensionless ratio is K is equal to epsilon by epsilon naught is called dielectric constant of the substance. In case of vacuum, capacitance equals epsilon naught A by D, whereas in case of any other medium, capacitance equals epsilon naught K into A divided by D. From the equations A and B, on dividing them, we get the value of K equals C by C naught. Thus, the dielectric constant of a substance is the factor greater than 1 by which the capacitance increases from its vacuum value when the dielectric is inserted fully between the plates of a capacitor.